One more problem real quick. We're going to work through the second half of problem 5B. And what the question asks us is, if you were to make the 1.2 millicoulomb and 9.1 millicoulomb charges stationary and remove the 6.4 millicoulomb charge, what would the electric field be at the point where the 6.4 charge was? Right, so what they're saying is, if we take the 6.4 charge out and we calculate the electric, what would the electric field be at this point where the 6.4 charge used to be, 6.4 millicoulomb charge used to be. So you might remember from your reading this week that the electric field can be calculated using K Q1 over R squared, right? So, but again, we would have two charges impacting an electric field. So we have to do the same thing where we're going to calculate E1, calculate E2, and then we would evaluate the overall electrostatic field at that point. So let's go ahead and do that. Same K, 9.0 times 10 to the 9th newtons meters squared per coulomb squared. Our Q is now large because it's now a fixed charge, but it's the same value, right? We've got a 1.2 times 10 to the negative third coulombs, again over R squared over 1.5 meters squared. And if we look at that, our E1 is then going to be 4.8 times 10 to the 6 newtons per coulomb. Now, one thing I want to talk about just real quick is how do we figure out the direction of electrostatic field. If you remember what we do for to determine the direction in an electrostatic field, we are going to assume that there's a positive test charge inserted. Okay, so if we insert a positive test charge, which way is the electric field going to point? Well, it's obviously going to point that way, right? So again, for this problem, E1 is going to point in this direction, and E1 would be 4.8 times 10 to the 6th newtons per coulomb. Okay, it would move that way once we insert a positive test charge. So now we're going to do the second electric field. E2, same equation, 9.0 times 10 to the 9th newtons meters squared per coulomb squared times 9.1, times 10 to the negative third coulombs divided by the radius, 2.0 meters squared. E2 equals 2.0 times 10 to the 7th newtons per coulomb. Okay, but again, we're looking at these two charges. Which way is the electrostatic field going to move? If we put a positive test charge in there, of course, it's going to move in this direction. So our field's going to point in that direction. So we have 2.0 times 10 to the 7th newtons per coulomb. Okay, so then to figure out our overall field, we have to do the same thing. So this then becomes negative. We have to add those up. This is the final. I'm not going to work through. It's the same math as we did in 5A, where you have to look at what precision you have. In this particular problem, we're going to take negative 2.0 times 10 to the 7th and add to that 4.8 times 10 to the 6th. What we get from that is actually negative 1.52 times 10 to the 7th newtons per coulomb. However, we only have precisions to millions, so we would report, oops, this is a 2. We would actually report an overall electric field of negative 1.5 times 10 to the 7th newtons per coulomb. Okay, now that's one way to do the problem. There's actually a simpler way you could do the problem as well. And what is that? Well, if you remember that we can calculate an electrostatic field by taking a force, dividing it by Q naught, and that gives you an electrostatic field. And how would we know what that overall electrostatic force is? Well, it's what we calculated in the first half of the problem. So we could also solve this problem by saying negative 1.0 times 10 to the 5th newtons, which was the electrostatic force that we calculated in the first half of the problem, dividing that by our charge that was there, which is that 6.4 times 10 to the negative third coulombs, and that gives us, it actually gives us negative 1.56 times 10 to the 7th newtons per coulomb. We only have 2 sig figs, so we would round that to negative 1.6 times 10 to the 7th newtons per coulomb. Now, you see these answers are not exactly the same. That is because of significant figures, but that is two different ways to find the electric field in this particular problem. Hope that was helpful.